Hi there. Today on the bench I've got an old UPS. It's an Upsonic 600 VA unit worth about $130 new. It was just going to the recycling, so I figured I'd crack it open for you guys to have a look. For reference, this is the battery that came out of it. It's just a Yuasa, it's like a 7 amp hour kind of battery. So let's have a look. It's just a clamshell design. And it came apart easily last time. What did I do? I think I just clunked it around. There we go. Okay, so there is parts connected to both halves of the clamshell. So you need to slide the transformer slightly before you can pull it out. But now it kind of splits open. Lay it all out on the bench. And so, a couple things I've noticed. Relatively thick gauge battery wires. I reckon these would probably handle 30 or 40 amps pretty steadily for the time that the battery could actually supply that. Transformer, it's on the small side for a 600 VA unit, but I think it could probably, again, sustain the output for how long this battery could provide it. Since there's only two wires going to the transformer, we know that the power electronics are a full H-bridge. So you see the 4 MOSFETs down in there, and the 2 big heat sinks. And essentially what that means is that instead of just sending chopped DC to both sides of the transformer, as with a center tap, this produces a full AC waveform, which then goes to the transformer. So it's a little bit more of an efficient design, and it's better for producing sine waves. I'm not sure if this is a sine wave unit, but if the microprocessor was taught to do it, it could probably produce a decent sine wave. Now, other than that, I'm looking down here. There is no fuse, so I wouldn't buy this unit just because it's a fire hazard or just a danger. Very little input capacitance. The wires aren't very long, so it's okay, but still they've just got one little 16 volt or 25 volt capacitor down in there to help smooth out the current going to the transformer, or rather to the MOSFETs. What else have we got here? Something interesting is you can tell this is designed for short-term use because the heat sinks on the MOSFETs are made for thermal mass rather than heat dissipation. So because they're just so big, they soak up a lot of heat before they get to a temperature that's dangerous for the MOSFETs. So if it only runs for 5 minutes, it could run at full load, and those heat sinks would get warm, but not hot enough to actually destroy the MOSFETs. But say you ran it for 15 minutes or 30 minutes, the heat wouldn't dissipate. There's just not enough surface area. Down in there you see the little fins. There's just not enough. And so it'd get hot, those MOSFETs would potentially break, or you'd at least smell it stinking, or something like that. You'd smell it before it broke. And that tells you that this is just not made for running for long periods. The other thing is, because it's a H-bridge design, it charges the battery through the MOSFETs. So there's no linear regulator or stuff, and if they're using pulse width modulation to charge the battery, then the MOSFET shouldn't get hot during charging. However, if this is one of those stupid designs where the MOSFETs are run in their linear region, just wasting power as heat to drop voltage from the transformer to charge the battery, then you have the potential for a bit of a fire risk, because these heat sinks will soak up heat, but they won't dissipate it quickly. So if you run this flat, the battery's flat, and you're trying to charge it, you might have an issue where the battery's pulling a lot of current from the charging system, and these heat sinks just get too hot, and then the MOSFETs break, and there's not much you can do then. So, yeah, you want to keep an eye on that. I personally haven't used this, so I don't know how hot it gets, but I imagine that after use, and especially during charging, you'd feel quite a bit of heat coming out of these spaces in the plastic molding. So that's just a brief overview. There's really not much else to look at. You know, you've got your filtering for power, you've got telecommunications filtering as well, just in the side there. You've got your daughter boards for the switch and the display, and that's about it. Thanks for watching. Have a great one.